This is R.D. Sharma Solutions, Class 11, Chapter 29, Limits exercise is 29.1. Now this is the first question, and this question is from NCERT. This is a NCERT question. Here we have a function. We have to show that this function does not have a limit. So let me tell you, this is limit x tends to 0, x by mod x, absolute value of x. So what we will do, we'll try to find out the left hand limit, right hand limit, and if the left hand and right hand limits are not same, that means the limit does not exist. Limit does not exist. So what we will do, see, please remember that whenever we have this x by mod x, what does it mean? It means that limit x tends to 0 and we have x by mod x. So if you are putting x as 0, what are you going to get? 0 by mod of 0. Mod of 0 will be 0. So you have 0 by 0, and that is ideal case of indeterminacy. This is not defined ever. You have 0 by 0, you have 0 into infinity, infinity minus infinity. We have others also, like 0 to the power 0, infinity to the power 0, 1 to the power infinity. All these boils down to 0 by 0 only, and that is indefinite. All these forms cannot be computed. We don't know it. It cannot be computed. So 0 by 0 is, of course, it's an indeterminate case. So what we do, we'll go for a limit, and then limit, we have to go for left hand limit and right hand limit. See, this is x equals 0. This is a critical point here because limit is x tends to 0. So we have left hand side, right hand side. So we have to come from left to this point, from right to this point, and we just want to get closer to this point. Not exactly this point, but close as possible. So we assume a to be 0. So whenever we want to come closer to 0 from left side, that is, we just stop at certain h point, that is a minus h, very close to 0. This h has to be very small number. We want it to be 0, but it's not possible, so it has to be very small. If we start from right hand side and we go up to this 0 point, what do we get? Up to 0 means we stop at h point, just h distance from a, but it cannot be 0 because it is undefined. So we will just stop a point just before 0, that will be some h point, that is 0 plus h point. So this is a plus h. So we'll stop at a minus h from the left, a plus h at the right. So this is the a minus h, a plus h we are going to put in the limits. So let me just show you here. This is limit. First we have to write in the limit form. So limit x tends to 0 minus. So 0 minus, that means left hand side we are approaching 0. And when we are approaching 0 from left hand side, x is equal to 0 minus h. 0 minus h. Okay. So 0 minus h you are going to get here. So 0 is, of course, a is the critical point. So 0 minus h we are going to put. A is fixed. So when we change the limit from x to a minus h, a is fixed. But h is going to be, we want it to be 0. So the limit change to h. Limit will change to h because x is already being given to a minus h. So x will be equal to 0 minus h. We will put x as 0 minus h. Now the limit will change from x to h. Now h tends to 0. So in place of x, you just have to replace x by 0 minus h. 0 minus h. So we have 0 minus h, mod of 0 minus h. This 0 minus h, what do you get? X is tending towards 0. So a minus h, that is 0 minus h. What is this h? It's h tending. We want this h to be as small as possible. As small as possible. So h tends to 0. H tends to 0. So we have limit h tends to 0 changed, and limit will be changed from to h tends to 0. And we have 0 minus h by 0 minus h in mod. Minus h will remain in the numerator. The denominator, this mod 0 minus h, because minus h will be in the mod, h will come out. Minus h by h. Mod means always positive will come out. It will be minus 1. So the left hand limit has come to -1. Similarly, this -1 as we got from the left hand side, we'll try to find out for the right hand side. As I said, we have to put a plus h, a is 0, so 0 plus h, 0 plus h. So now you have to change to x tends to 0 plus, because we are talking about the right hand side. So 0 minus 0 plus h you have to put 0 plus h. Now when we change from x to 0 plus h, we have to take h as small as possible. We ideally want to be 0, but when it becomes 0 it will be indeterminate. So h has to be very small. So in place of x you put 0 plus h. You will get, now limit x tends to 0 plus will change now. It will be h tends to 0. X tends to this 0 plus superscript is change. So this is 0 plus h by 0 plus h in the mod. So now limit change to h now. Limit change to h now. So we have 0 plus h by mod of 0 plus h, and this in the numerator we have h by h, because mod h plus will come out. So it will be 1, h by h cancels. So now 1 is right hand side limit. So left and right hand limit are -1 and 1, which are not equal. So when these limits are not equal on either side, that means limit does not exist. It doesn't exist. So why did I explain you? Because most of the questions are like this only. Same concept you are going to use everywhere almost. Now question number 2 we have. Now find k such that limit fx x tends to 2 may exist for where fx equals to, there is a proper function. This function is telling you that if x is less than 2, 2x plus 3, x is greater than 2, it is x plus k. So what is the significance? How do we perceive this question or with this function? Let me show you here that we are talking about, just take me to the number line. This is x equals 2. This is a critical point. It is saying that it is a critical point, but it is not going to be 0, infinite, right? Anything. So we are talking about left hand side and we are talking about right hand side. So left hand side means 2x plus 3, and right hand side is, so if x is less than or equal to 2, we have to take y equals 2x plus 3. It is a straight line. When we have right hand side, that is if you go up 2 or add something to 2, it has to be x plus k. It has to be x plus, so right hand side. So you are talking about x plus 2, x plus k, x plus k. So when we take left hand limit and right hand limit, then we have to find out k for it. K is not known. Limit x is existing, so left hand, right hand equate. That is going to be the way we find out k. So now we have a is 2. Left hand limit, a is 2 is the critical point. So a is 2. So there is small h before 2 we are going to stop. We start from left hand side. So we have to put x as a minus h, that is 2 minus h. 2 minus h. And then we have this right hand side. When we approach 2 from right hand side, we'll stop near 2. Means about h distance from 2. So 2 plus h we are going to put. So let us take left hand limit and right hand limit. 2x plus 3, and this you have x plus k. So left hand limit, you see, limit 2 minus, this is x is 2 minus. So we have 2 minuses from left hand side. So fx will be equal to limit x tends to 2 minus. And when we are talking about left hand side, that is below 2 or equal to 2, it's 2x plus 3. 2x plus 3. So this is 2x. We will change to 2 minus, because we have to change the limit to h. So limit h will be tends to 0. H has to be as small as possible. So in place of x, I am putting 2 minus h. In place of x, I am putting 2 minus h. We have to replace x by a minus h. A is 2 here. So just solve it. H tends to 0, so you can just remove this. 2 into 2 is 4. 4 plus 3 is 7. So we have limit h tends to 0. H you have to remove because you are putting h as 0. When you put h, just forget about h then. Limit have already been applied. So you have 7 here. This is left hand limit. Now coming to the right hand limit. Right hand. Now for this, function has changed. Function has become x plus k now, because we are going up to. So we have this as limit x tends to 2 plus h. So 2 plus, when we'll put 2 plus, that is we are going to on the right hand side. So fx will be equal to, the function is going to change. It will be now x plus k. So x tends to 2 plus, it will be what? It's x plus k, x plus k. Now this x plus k, now you know that we have this 2 plus, we have to replace by 2 plus h. So we have limit, now we have to replace the limit also. It will be h tends to 0. 2 plus, so 2 plus h, we just go up. So in place of x, you put 2 plus h. So 2 plus h plus k. Now h is tending to 0, so when we put h tends to 0, we'll not use the limit. So you have 2 plus k. So this will be 2 plus k. This is right hand limit. Now left hand limit, right hand limit. Left hand limit, right hand limit. So we have left hand limit equal right hand limit. It has to be equal. So k will be equal to 7 minus 2, that is going to be 5. So k will be 5 for LHL to be equal to LHL and the limit to exist. Now question number 3 we have. Show that the limit x tends to 0, 1 by x does not exist. So what we will do, I'll just show you what does it mean actually. So we have left hand limit and right hand limit we are going to find out, and we'll show that they are not equal. They are not equal. So 1 by x, where the problem is, when you put x equals 0, 1 by 0 means what? It is infinity. Whenever you divide anything by 0, it's infinite. It's infinite. So critical point is x, when you put x equals a plus h, x minus h on the right, for right hand one, so you have a as 0 and a as 0, so 0 plus h and 0 minus h. The left hand limit, right hand limit, okay. So just put it here. So limit is 0 minus, so we are showing that it is on the left hand side. We are talking about left hand side. So 1 by x, now put x as 0 minus h. 0 minus, oh, I need to change it. There is a slight error. This is 0 minus h, a minus h, this is a plus h on the right hand side, and so 0 minus h I am putting on the left hand side. And 0 minus h, now you have to change the limit of h also. So if you put h as 0, 1 by minus 0, 1 by 0 is infinite. As I told you, 1 by 0 is infinite. 1 by minus 0 is minus infinite. Minus infinite. Infinite is what? Infinite is any number which is not countable. We don't know that infinite number. It can be anywhere. No. So when we go to right hand side, 0 plus h I am putting. You have 1 by h. 1 by h is again infinite. 1 by 0 is infinite. So you see the left hand and right hand are not equal, because infinite is a number. It's a proper number, but we cannot define it. If you come with any number, I'll just add 1 and I'll say this is not infinite. Infinite is the end point of this number line, which is not known. We will never reach that highest number. It can be, you can go to highest number to any extent you want, but we know that there is a number. Infinite is just a representation. So that is the solution. Question number 4. Now we have to show that the limit x tends to 0, e to the power minus 1 by x does not exist. So we'll do the same thing here. So I'll just show you what we are going to do briefly. So we'll say limit x tends to 0, e to the power minus 1 by x. Now we know x tends to 0, that means it's a critical point. That is the point where we have to check, and the limit is discussing. We are discussing. So x equals a minus s, x equals a plus h, left hand side, right hand side. So 0 minus h we are going to put in the left hand side, 0 plus h we are going to put in the right hand side. Okay. So we have limit. Now 0 plus, what does it mean? 0 plus, you have to put 0 minus h. No, 0 minus. In terms of 0 minus, we are going to put e to the minus 1 by 0 minus h, because we are taking left hand limit. Minus 1 by 0 minus h, minus 1 by minus h, it is minus 1 by minus h. What does it mean? Minus 1 by minus cancels, it's 1 by h, and 1 by h is infinite, 0. So 1 by 0 is infinite. So it is e to the power infinite. E is a proper value, 2.732 I guess. And if you go to infinite, it is infinite. Now coming to the right hand side. So we have e to the power minus 1 by, in place of x I am putting 0 plus h. 0 plus h. So it is minus 1 by h. E to the power minus 1 by h. So e to the power minus 1 by infinite, 1 by 0, that is e to the power minus infinite. E to the power minus infinite. So when we have e to the power minus anything, we can always write it as 1 by e to the power plus of that thing. So 1 by e to the power infinite. E to the power infinite is infinite. So 1 by infinite is what? So if you want to divide 1 by infinite, any number which is very huge, it is going to be 0. Ultimately, it is going to be 0. Anything which is having multiple, you can't even count zeros. If you divide 1 by or any number by infinite, it is going to be 0 always. You will never reach that infinity, because that number I will always add 1. I will say this is the infinity. So infinity is a proper number, but we don't know it. It goes beyond our comprehension. But 1 by beyond our comprehension division is 0. So you have left hand limit, right hand limit, infinity and 0. They are not equal. So limit does not exist. So let me show you formally. So we have limit here. We started with left hand limit, so 0 minus, and right hand 0 plus. In place of x, we put 0 minus h in the left hand side and 0 plus h on the right hand side for the right hand limit. So we have x tends to x when you put 0 minus h, here you put x as 0 plus h. So we have 0 minus h. Now h tends to 0. Both the sides, h tends to 0, you have to change. So it will be infinite, and e to the power on the right hand side, you have e to the power 1 by minus 1 by 0, that is going to be minus infinite, as I just told you. E to the power 1 by e to the power infinite is going to be, or infinite is going to be 0. Just remember, anything to the infinite is infinite. Anything below, whenever we have division, when you have infinity in the below, it will be 0. So this left LHL, RHL are not equal. Limit does not exist. Now question number 5 here. Now I hope the concept is clear to you. So we have here question number 5. Yes, 5. Show that. Let me write the question here so that you understand. And here we are going to use the greatest integer function, or this square this one. So we have this question. Let me write the question first, then I'll explain. So we have x by this square bracket. Okay. So we have left hand limit, and you have right hand limit. So we have this 2 minus 2 plus. This is given in the question. Here we can see easily that the critical point is what? 2. A is 2. So x will be written as 2 minus h left hand side. X will be 2 plus h on the right hand side. 2 minus h, 2 plus h. So when we put it here, if you see this 2 minus h, I am putting just 2 minus h and 2 minus h. So this 2 minus h, this function I am going to tell you, this is the function that simply means you have to take the lower integer, whatever value comes. So 2 minus 0.5 is 1.5. So you have to take 1. I'll just show you with some more example. Whatever number you take, this 2 minus h will be between 1 and 2. If you subtract any number, that is 0.1, 0.2, say 0.2, if you subtract, what will be? 1.8. You have to take 1. If you remove 0.5, 1.5 will come. Then again you have to take 1. Means the 1 will come out. 1.2, 1. So in between 1 and 2 integer, you have to take always 1, the lower one you have to take. So 2 minus h, if you subtract something from 2, it is going to be somewhere near 1. You have always to take 1. So we have 1 always. Integer value you have to take, and that will be the lower, you can say the floor you have to take, floor. So 2 minus h, you are putting 2h as 0, so 2 minus 0 by, and 2 minus h, of course, in the function it will come out as 1 always, because you have to take between 1 and 2, and 1 will always come. So you have 2 by 1, that is going to be 2. On the other one, you have this one, right hand. Now right hand, this is what do you have to do for right hand one? You have 2 plus h by, this is 2 plus h again. Now I told you that whatever you do, you have to be between the integers and you have to take the lower one. So if you add anything to 2, say 2.2, 2.5, 2.8, whatever is the value between 2 and 3, always 2 will come out. This square bracket function always tells you that, right? So you have 2 always in the denominator, 2 plus h, that is h is 0 always because h tends to 0. 2 plus 0 by 2, so you have 2 by 2, that is going to be 1. It's going to be 1. So you have 1. So right hand is 1, left hand is 2. So they are not equal. That means the limit does not exist. This question number 6, this we are going to take in the next discussion. Okay. Till then, thank you so much. Take care of yourself.